Welcome to today's 3.3 lesson on the properties and organization of the periodic table. Here's your catalyst. When you are done, please make sure that you check with a neighbor. So, organization of the periodic table. You will need some pens or markers and some colored pencils. All of those things should be located at the front of the room for you. You all should have received a black and white periodic table. I'm going to sort of walk you through some of the instructions. It is pretty self-explanatory, but I really want you to pay attention to labeling things correctly and know that you are responsible for knowing the properties of each type of element that we look at today. This is a colored version of your black and white periodic table. Please pay really close attention to what you're asked to do. There are not enough extras for everybody to make a mistake, so if you make a mistake, do the best you can to fix it. There will be a few discrepancies here and there. Please follow the labeling that you see up here. See how the M represents metalloids? So when you're asked to color the metalloids, please follow these labels in the lower right hand corner. Whatever color you decide to color a particular group, make sure that you also label it in your key. So if you want alkali metals to be orange, make sure that you color in alkali metals orange here. If you want it to be green, make it green. I don't care, it's your periodic table. The first thing we're going to talk about is the periods on the periodic table. So periods are the rows on the periodic table. They go 1, 2, 3, 4, 5, 6, 7, and they tell you your energy level. Notice down here that I have the lanthanides and the actinides. Those actually fit right in here in the periodic table. We move them out of the periodic table in order to make our periodic table a little bit smaller and more manageable. These are already labeled on your periodic table, but please note in your notes that the periods reflect the energy level. Along the top we have our groups or our families. This is labeled 1 through 18. Sometimes you'll see it 1 through 8A, and then you'll see 3 through 12B here. We're going to go ahead and label it 1 through 18. Notice here 1 and 2 is highlighted, and then once we jump over here, the 3 of 13 is highlighted, the 4 of 14 is highlighted. That just tells you the number of valence electrons. So in group 1 we have 1 valence electron, group 2 we have 2 valence electrons, group 13 we have 3 valence electrons, then 4, 5, 6, 7, and 8, with the exception of helium up here, which will only ever have 2. Let's do a quick understanding check. So how many valence electrons does bromine have, and how many energy levels? If we come here to our periodic table, I've got bromine right here. It's in my 17th column, so it has 7 valence electrons, but it's in my 4th row, my 4th period, so I have 4 energy levels. And back here, how many valence electrons does magnesium have, and how many energy levels? Here's magnesium right here. So I'm in my 2nd column. That means I have 2 valence electrons. And I'm in my 3rd row. That means I have 3 energy levels. Okay, so pretty simple. There is a staircase that separates the metals from the non-metals on your periodic table. So it tracks like this here. I want you to go ahead and label metals to the left, non-metals to the right. Here's a better picture that shows you the staircase right here. Our metalloids surround the staircase. I want you to go ahead and take a moment. You are going to outline all of the elements here for my nonmetals and my metalloids. So all of the nonmetals should be outlined in purple, not filled in, just outlined. And every metalloid should be outlined in red. Every metal is going to be left blank, so don't put an outline on it. I want you to go ahead and write down the properties of all metals. So they are found to the left of the staircase. They are lustrous, meaning they're shiny. They're generally hard, although not all of them are hard. They're very dense. They are malleable, which means that they are moldable. They are ductile, which means you can draw them out into wires. And generally, they have high melting and boiling points. They're always good conductors of heat and electricity. They are not always solid. Mercury is an example of a metal that is not a solid at room temperature. And they don't always have high melting or boiling points. So gallium, for example, can melt in your hand. Your nonmetals are found to the right of the staircase. This also includes hydrogen, which is still to the left of the staircase, and we'll talk more about that later. Your properties of your nonmetals are that they tend to be very dull and brittle. They are very poor conductors of both heat and electricity, and they have very low melting and boiling points. Your metalloids, or those elements that are on the stair step, are really just a blending of the metals and the nonmetals. So they are slightly lustrous, they have intermediate melting and boiling points, and they are semiconductors, which means that they conduct electricity a little bit, but not great. And we use these semiconductors a lot in any sort of electronic devices that we have. So again, make sure that you have this written down. Okay, we have two liquids at room temperature on our periodic table. I already mentioned one of them, which is mercury. The other one is bromine over here. I want you to circle both elements in blue. Our gases are noted here in green on this periodic table. It's hydrogen, nitrogen, oxygen, fluorine, chlorine, and then all of our noble gases here. Take a moment and circle them all in green. Now, we have 7 elements on our periodic table that are always found in pairs in nature. They're just not stable enough to exist by themselves, so we always find them together. They're called our diatomics. So if you think about that, di means 2, and atomic is referring to atoms, so it's always 2 atoms together. And that's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There are a couple ways to remember this. You could just memorize this. You can do the 1 plus 7. So here's my 1, and then this makes the shape of a 7. You can use Crazy Uncle Brinklehoff, which is what I usually refer to it as. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Or you can use the acronym HAVE NO FEAR of ice cold beverages, right? So have no fear of ice cold beverages. Any one of those you can use to help you remember what your diatomic elements are. But it is very important that you remember what your diatomic elements are. Go ahead and on your periodic table, what I want you guys to do is I want you to put a 2. I know it's a little hard to see in this image, but I want you to put a 2 next to all of your diatomics. So I have H2, N2, O2, F2, Cl2, Br2, and then I2, just to sort of remind yourself that you will always find those together in nature. So let's walk through some noteworthy groups here. You will need to write all of these down, and again, whatever you decide to color them, make sure that you label it in your key. The first group is our alkali metals. They're very, very, very reactive. They're never found pure in nature. They're generally very soft and silvery in color. As you go down the group, they get more and more reactive. Notice that hydrogen, although it is above the alkali metals, is not itself an alkali metal. Your alkaline earth metals, group 2, are less reactive, but still very reactive, also not found pure in nature. The word alkaline means basic, so when we talk about acids and bases later in the year, we'll sort of cycle back to alkaline. But you have these group 2 metals generally form bases. So calcium hydroxide, magnesium hydroxide are 2 common bases. Your transition metals is group 3 through 12. The properties vary, but they generally are more stable. You will see over towards this end, you'll see elements that are very stable and what we use for currency. So copper and silver and gold, those are all very, very stable metals. Your halogens, group 17, are very, very reactive. They're never found pure as elements in nature. Most of them are diatomics. They are nonmetals. They are most reactive at fluorine, so as you go up the periodic table, as opposed to going down the periodic table with your alkali metals. Your noble gases are only found pure in nature. They are inert, which means that they are unreactive. There are some exceptions in your heavier noble gases, but I don't need you to know that. They are colorless and they are odorless, and being unreactive, that makes them among the last group of elements to be discovered, and they are considered nonmetals. Your lanthanides and actinides are the 2 groups that were pulled out of the periodic table and placed at the bottom. Your lanthanides are very, very, very rare. These are called the rare earth metals, both the lanthanides and the actinides. They tend to be silvery white. They're often used for things like hybrid cars, superconductors, magnets, things of that nature. Your actinides are mostly man-made, so anything beyond uranium at 92 is man-made. And so most of our actinides and beyond, we've actually made in a lab. They are radioactive, and both the lanthanides and the actinides are very reactive metals. Okay, so we're going to talk about this a little bit more later, but I want you to go ahead and label the blocks on your periodic table. So your alkali metals and your alkaline earth metals are what's called the S block. Everything 13 through 18 is called the P block. Your transition metals is called the D block, and your lanthanides and actinides are called the F block. Go ahead and take a moment to label them now. Again, we'll come back to this in the next few days. Here you go. This includes helium for your S block. Helium actually moves over. Again, we'll talk about that later. This is one of 2 parts of what are called the representative elements. The second half of the representative elements is the P block. Again, that's groups 13 through 18. Now remember, helium here is going to move over to the S. And this contains the group called the other metals. Your D block is all of the transition metals. And then again, your F block is the lanthanides and actinides. Just a reminder, it gets pulled out of the periodic table and moved below so that we can fit the periodic table onto a single page of paper. But we still have to keep that in mind, because as we move forward, this 4F and 5F that we see right here will become really important, and we have to remember that the F block does still get inserted in the periodic table. Okay, so like I was saying, anything beyond 92 is considered a synthetic element. So notice here, all of these elements are synthetic all the way through here. We actually are all the way out to element 118 right now. Technetium and promethium are both also considered synthetic because they're not found on Earth, so we've had to make them. Okay, make sure that you have labeled everything, colored everything, and written everything down. You are responsible for all of this information.